Okay, now we're going to use substitution to solve systems of linear equations. To start with this first example, what I'm going to do is label each of my equations, one with a little 1 and a 2. And that way I can easier tell which equation I'm working with in each step. So what we want to have is something like this, where we have one of our variables solved for, and then we are going to want to substitute it into the other equation. So let's kind of work through this scenario. It's kind of convenient that equation 1, y is equal to 2x plus 1, this is already solved for y. So I can take this statement, 2x plus 1, and plug it right into the variable y in the other equation. All right, so here is how we do that. Okay, so we're going to take equation 2. All right, the 3x plus 2y is equal to 16. All right, and everywhere I have a y, I'm going to go ahead and open up a set of parentheses. So 2 and then y, it's got to be big enough to fit that 2x plus 1 in, is equal to 16. And so now what I'm going to do is I'm going to take the 2x plus 1, and that will get plugged into the y's place. All right, so now what you see here is we have an equation where the only variable is x. Now I can take this, simplify it, and solve for x. So we'll have what? 4x, and then what? Plus 2 is equal to 16. Combine like terms, right? We got the 3x and the 4x to get 7x plus 2 is equal to 16. So now I want to subtract 2 from both sides, right? Okay, so it'll cancel here on the left, and I end up with 7x is equal to 14. Now let's divide both sides by the 7 that's multiplied by the x, right? Okay, and so the 7's cancel, and I have x is equal to 2. So now that I have x is equal to 2, right, that's my first coordinate, I can take equation 1, which is y is equal to 2x plus 1, and I can plug in this 2 for x, okay? Now we can easily find the variable y. So I'm going to plug in what I got for x, which is 2, into the other equation. So now we see that y is what? 4 plus 1, that's 5. Okay, so we have our ordered pair 2, 5, right? X, y. So to verify your solutions, you'll want to plug x and y that you just solved for into both equations to make sure you get a true statement. So notice our first equation was y is equal to 2x plus 1, and the second equation, 3x plus 2y is equal to 16. For the first equation, y is equal to 2x plus 1, we'll plug in our 2 for x and our 5 for y. So we get 5 is equal to 2 times 2 plus 1, right? There's your y and there's your x. And now let's go ahead and simplify it and see if we get a true statement. We have 4 plus 1, and we do. So it works out for the first equation. So let's now go to the second equation, which is 3x plus 2y equal to 16. And we'll plug in our x and our y. So 3, open parentheses, and what do we have for x? We have 2. Plus 2 times y, y is 5 in this case, and equal to 16. Let's simplify. We have 6 plus 10 is equal to 16, or what? 16 is equal to 16. So this solution, 2, 5, checks out for both equations in my system. So that is correct. It is a solution. Let's go to the next example. So again, I'm going to mark the first equation as equation 1, the second one is equation 2. So notice this pair of equations is not quite as convenient. So I'm going to take equation 1 and I'm going to solve it for y or x. Either one would be fine. So, well, let's go ahead and solve it for x by subtracting y from both sides, right? And now x is 3 minus y. So now I can take this new version of equation 1 and substitute it into equation 2. So wherever I see an x, I'm going to plug in 3 minus y. All right, let's continue. So we have 2y is equal to 2 times the x. Okay, we'll get there. Coming back to plug it in. Put a 3 minus y in place of x. Now we can solve this equation, or this version of equation 2. We can solve it for y. So let's begin by distributing the 2 to get rid of those parentheses. And we'll have 2y is equal to 6 minus 2y, and then plus 6. Let's go ahead and simplify and get y by itself. Working through it, we'll have 2y. I'm going to combine 6 plus 6, which is 12, minus 2y. And now I'm going to add this 2y to both sides. It'll cancel here. And I'll end up with 4y is equal to 12. Divide by the 4 on both sides, right? Cancels here. And now y is 3, right? 4 goes into itself once and goes into 12 3 times. Okay, so I have my y, and now I can kind of go back up here to that newer version of equation 1, and I can plug in my y to find x. 3 minus 3 is 0. So we have an x and we have a y, right? Here's our ordered pair, 0, 3. Okay, let's verify our solution, 0, 3. Remember, 0 is x and 3 is y, right? We have to check both equations. So for equation 1, that's x plus y is equal to 3. And here's equation 2. I'll just write it over here. 2y is equal to 2x plus 6. Okay, so now we're just going to plug in 0 and 3 for both of the equations. So x is 0 plus y is 3. So that checks out. So 3 is equal to 3. So let's check it for the second equation. 2 times y, remember y is 3. And then is equal to 2 times x, which is 0, plus 6. This whole term zeroes out. So we'll have 6 is equal to 6. So this solution checks out with both of the equations. So it is a solution to the entire system of linear equations. Yay! Okay, one more example. First equation will be equation 1, and second equation's labeled with a 2. So if you look closely, you'll see the second equation is already solved for y. Yay, we like that. Okay, so I'm going to take equation 2, and wherever in equation 1 I have the y, that's where I'm going to plug in negative 2/5 x. So let's do that. All right, so we'll have 2x plus 5. I'm going to open a set of parentheses big enough for negative 2/5 x. All right, is equal to 15. So let's go ahead and plug in negative 2/5 x and simplify. So we'll bring down the 2x. Now you'll notice here that 5 over 5 is 1, so the 5's do cancel out, and you end up with minus 2x equal to 15. So here's what's going on here. We have 2x minus 2x, which simplifies to 0. So what is happening here? So when your variables all cancel out after you've substituted, and you end up with a false statement. So 0 is definitely not equal to 15. What you should conclude here is that there are no solutions to this system of linear equations. And I'll tell you why. Here I am using the Desmos.com graphing calculator. It's an online graphing calculator at desmos.com/calculator. And if you look closely, I've gone ahead and graphed 2x plus 5y is equal to 15, right? That's the red line. And y is equal to negative 2/5 x is the blue line. And they are parallel. Note that they have the same slope. And so they never intersect. You can just look for the y-intercept. If they don't share that and they have the same slope, they would be parallel lines. That's why we say there's no solution. Everything's canceling out here, and you notice that you don't have two values that equal each other. Keep practicing, everybody. I'll talk to you soon.